Hello everyone and welcome to our first video on programming with the JavaScript programming language and P5.js for the Intro to CS Async course this year. Remember, the website is very simple to get to. It's p5js.org. We're going to be using the online editor. And again, everything that we talk about in this video and other videos, you can always find more information in the reference section, the learn section, and potentially the examples section. So let's go ahead and get started. I'm going to click Start Creating with the P5 editor. Make sure when you start, you're logged in, so you can see I'm already logged in with my Hulton account. So anything I create, I can save and keep for future reference. So as you work on stuff and you try out things, and eventually you'll get to an activity where you're going to make your own small program, you'll be able to save it and eventually show it off, or at least keep it online as you go. To start, again, I'm going to run the program they give us. It's very simple. It gives us a kind of gray drawing area, and so we'll talk about some of the things. First, most important, some terms we are going to hear or see are function or command. And essentially what's going to happen is when you program a computer, you tell it to do certain things. Usually those things can be very simple, but they can become very complex quickly. So for example, something as simple as adding two numbers might be a command for a computer to follow. But something more complicated, like drawing multiple colors and having it transition every couple seconds and having a box bounce off the edges of a screen. I mean, there's so many things you can do. The idea is that essentially a program is a collection of steps or commands that the computer needs to follow. In our programs here, there are two things that we have to kind of always be aware of in how our drawing program, you can imagine we're kind of like writing code to draw paintings or animations or pictures. And all the commands are related usually in some way to some visual representation of something. And so the code that's given to us is kind of the initial setup. And we can see there are two things that we want to talk about, and they even use the word function. The first one is called the setup function. This is a piece of code that runs one time at the beginning of your program. And what they give it to us initially for, and we can do the same and we can change it, and we might add more in the future, is to basically set up where our drawing area is. We call it a canvas. So we very much will use kind of the art terms that you might know from your art classes. So you paint on a canvas. In our code, we are going to draw things or display things on our canvas. The create canvas command within setup says, okay, well, let's make the area we're going to draw. But we have to know how big it is in pixels. Remember, your screen is made of millions of little pixels, and so and it may vary based on the type of screen you have, how much space it takes up on your actual computer. But in this example, you can see that I'm saying 400 and 400, and so what I'll say is that first number is how wide our drawing area will be, our canvas will be. The second number is how tall our program will be. So in this case, it's 400 pixels wide, so that goes about this way up to 400. And then this one is 400 tall, so down this way, 400 pixels. And we can prove this by changing the numbers. Let me go ahead and make this thing 600 by 400. And so if this is the width, I should see this gray area become longer to the side. If I press play again, there it is. You can see it's much longer. And I have a lot of empty space, so I could make mine bigger. You can pick numbers that fill as much of your screen as you want. If you're on a smaller laptop, obviously this will take less space. I can also shrink my coding area so I have more space to draw. But generally, I don't play with the numbers too much. But I will make mine a little bit bigger, 600 by 600. So if I press play again, a much bigger area. My canvas can be larger. And again, it's just a matter of what you like, how much space you want. It does impact other things in the future, but as long as we're aware of those numbers and what we chose, we can edit them or refer to them in some way. So setup happens once. So we only want to make that canvas, that drawing area, at one time. What we want to do maybe more often is draw something. So the second command or function they give us is called the draw function. Now this one's a little more complicated because instead of happening once in the program, it actually happens an unlimited number of times. Essentially, once your program starts, it happens again and again and again. In fact, the draw command tries to happen 60 times per second. And if you know anything about how movies are made or graphics in games are made, essentially animations, visual changes on screen are the collection of thousands, if not millions of pictures running one after the other very, very quickly. So on our computer screen, if we have things moving, it's an illusion. It's actually just many, many individual static pictures that are kind of shown quickly to us. And eventually the illusion on our eyes is that things are moving. And that's the same for movies, for drawings, cartoons, things like that. And in our program, this is also the case. Now, At this point, nothing's moving, so we're basically drawing a giant gray square 60 times per second forever, as long as our program's running. So there's no change, but the reality is you can imagine, and this is not what we can do in something in real life, but if an artist drew a painting really fast on a canvas, and then threw that canvas away and put a new one, and then drew another drawing slightly different, and then threw away that canvas, and then made another one, the program is basically doing this 60 times per second, which is very, very fast, and that's how we can get like smooth movements and things like that. For our purposes, we're just going to draw static pictures for now, and maybe we'll have time to get to moving things. Or in the future, you can look into making things move, and that's a lot more interesting. This background command in the draw, it's saying we want to pick a background color. And notice they give us a number. They don't say gray or light gray. Unfortunately, that's one limitation we have, but we can actually change the color pretty easily. We just have to know some rules. So I'm going to put some notes here for us, and you can always refer to them. You can also look up in the examples and references how to do this. But I'm going to put notes by putting 2 slashes, and basically this is not code. It's just for our, reading, for humans to read, and so for our examples. And the rules are simple. We'll start with 2, and there's a lot of them, but we'll start with 2 of the most easy rules for colors and background. If we give the background command 1 number in the parentheses, this number represents a grayscale color. So that means between black and white and then anywhere in between. So really dark grays, light grays, no gray, which would be potentially all black, or all gray as much as you could, which would end up being all white. So it's only black and white essentially, or somewhere in between. So I'm going to go ahead and put that note. If 1 number is given, we get a grayscale color. The range, so the range of possible numbers, because we could put any number you can imagine, but to control kind of how much detail we have, they give us a range, is from 0 to 255. So you can see that 220 is pretty close to 255, so the higher the number, and we'll say low is equal to black, and high is equal to white. So the higher the number to this range, the closer to white it's going to be. The lower the number closer to 0, the darker it's going to be. So let me go ahead and change this number to 50. That's much closer to 0 than 255. So when I run my program again, we can see it's much darker. It's not black, but it's pretty dark gray. So 1 number gives us a grayscale color. And again, I can do 0. We can see completely black. If I do 255 and I run it again, that's totally white. So now that's potentially dangerous just because I don't know where the edge is of my drawing, but it is there. And so again, they gave us 220, and that was somewhere closer to so I'm going to put 100. And there's a much darker background. And you can pick whatever background color you want. But of course, grayscale is fine. But if we want color, actual color, we want to kind of go more advanced. So now let's put some more notes. The second rule, which we can use to make colors in the background, is if we give 3 numbers. So instead of just 1 number, we can give 3 numbers. So let's take a look how we do this. I'm going to put notes. So if 3 numbers are given, then essentially what we're saying is each of these numbers represents a portion of the color, and this does change based on what kind of computer system you're on and what you're trying to do. There's a lot of history in terms of how these things are managed. But in the modern day, one relatively easy approach, which also maps to the physical design of actual pixels on your screen, which with our eyes is really hard to see. You'd have to get really close up to a screen or TV screen to notice the little colors in the pixels, and even then it might be hard to do because of how advanced our computer screens have become. But essentially there are 3 parts to a color on a computer screen: a red light, a green light, and a blue light. And every color that you see on screen is some combination of redness, greenness, and blueness. So when we give our 3 numbers, they're going to map to how much red do you want, how much green do you want, how much blue do you want. And the combination will generate colors, right? So I'm going to go and say if 3 numbers are given, the first is how much redness, the second, how much greenness. And I know maybe those are not words, but I'll go ahead and do that. And the third, how much blueness. Right? So again, we can pick. And so we call this, and I'll just go ahead and put this in a note, we call this RGB, right? That's a short term for red, green, blue, and the order is going to be in that order. First we give a red number, then we give a green number, and then we give a blue number. The range for each color is also 0 to 255. So I'll go ahead and put that last thing. Color ranges, 0 to 255. So let's try this out. I'm going to start off with red. Red is my favorite color, so we'll stick with all red, no other colors. And so what we're going to do is the lower the number, the less of that color there is. The higher the number, closer to 255, the more that color. So if I want as much red, bright red as you can make, I'm going to say I want 255 red. There's no more, any higher than you can go than 255. So I want maximum redness. Greenness, if I want pure red, I can't have any green, so I'm going to put 0 for my greenness. And then for the blueness, the same. If I put any blue, then it might not really be red, so I'm going to put 0 blueness. And I'm going to go ahead and run this, and we'll see what happens. Red canvas, right? In painting, you probably typically use a white canvas or maybe even a black canvas. But here the idea is, imagine if you painted over that canvas with the color, in this case, red. And now, basically, every color you can imagine is just some combination. So let me just put random numbers. I'm going to put 173, I'm going to put 45, and I'm going to go ahead and put 100. So we can think about this before we even run it and say, well, okay, this is a lot of red, not maximum red, but a good amount of red. More blue, so about half of about the amount of blue that we could potentially have, and less green. So the combination of a good amount of red, a little bit of green, and a reasonable amount of blue will give us some color. If I press it, it's kind of between purple and pink, dark pink, I guess. And we can play around with the numbers and get any color you can imagine. And of course, I don't know enough about colors and the mixing to get exactly what color will happen or to guess it. So instead, we'll do something easier than that. We'll just simply Google a color picker, and Google will have one for us, and we'll see how we can visually pick a color and then find those 3 numbers. So I'm going to go ahead and open up Google and say color picker. And there it is. And you can see what Google does for us. It gives us a nice visual color selector, and I can pick the color. So let me go to this dark purple. You can see somewhere here. And notice what happens. As I pick my color, 1, I pick the general range of color, and 2, I can pick, where in this color scheme. And so as I select on here, you can see this is the color we're going to get. So maybe if I go to a darker green, there it is. And as you do this, notice on the left here we have RGB. And those are the 3 numbers. So 43 for red, 117 for green, and 8 for blue. So almost no blue. I'm going to copy these 3 numbers. So I'm going to copy them. I'm going to go back to our editor, and I'm going to paste them into these 3, and I'm going to run it. And you shouldn't have to ever memorize which numbers. Maybe the red, green, and blue are easy because they're just all one color. But any other fancy, nice color you want to pick, just look it up and get the numbers, and then place it in your command, and you now have the background of your choice. So it's important to recognize that color selection is important. For now, we're just doing the background. In our next video, we're going to see how we can use this color on lines and other things to make other visual representations. But the first step is always having a good background to play with. So we're going to stop here. In our next video, we'll talk about how we can draw lines and change their colors, change where they show up on screen, and then maybe change how thick those lines are. I'll see you in the next video.